Hello everyone. Another question on motion of projectile. I think this should be lesson 10. Yeah, lesson 10. A boy is standing on the beach and his sister is at the top of a cliff 10 meters away at a height of 8 meters. He throws her an apple with a speed of 15.5 meters per second. In what direction should he throw it? So, looking at this question, okay, now I have not solved the question, but I'm sure that it's a question that requires, careful examination. I mean, we look at it carefully and then look at how to navigate. All right. So now, um, so we are given that the boy's sister is at the top of a cliff 10 meters away. So I'll take that to be horizontal distance. Okay. And then at a height of 8 meters. So I'll take that to be vertical distance or vertical height. All right. So the boy throws her an apple with a speed of 15.5 meters per second. Of course, that will be the initial velocity or speed. In what direction should he throw it? So now, with the way the question is given, now it means that we can use we can start by using what we call coordinate system to describe or to define the position of the boy and that of the sister. Now let's see how that works out. All right. So in this case, we can say let the boy's position, okay, let the boy's position, yeah, be defined by the coordinates by the coordinates 0 and 0. Now, the 0 represents horizontal distance. The second 0 also represents vertical distance or vertical height, meaning that the coordinate of the boy, because the boy is standing on the beach, the boy is at the what? Datum level. So horizontal and vertical distance will be 0. So now, but let's look at that of the girl. That's the boy's sister, and his sister is at the top of a cliff 10 meters. So which means we can say let the boy's sisters or let the sister's position let the sister's position be defined by the coordinates by the coordinates by the coordinates. So now we have that she's at the top of a cliff 10 meters away. That will be horizontal distance will be 10 meters, okay, at a height of 8 meters, and that will be 8 meters for y. Okay, so this is x and y. This is also x and y in this case. So the initial speed, okay, is given to be 15.5 meters per second. That's it. All right. Okay. Now, because we want to know in what direction should the boy throw the apple. So what we are going to do now is here we have x and y. Okay. So which means so we can now what? We can just write down the equation for x and y. Okay, using the velocity we are given. That's the initial speed. So we know that horizontal distance, which is x, is equals to horizontal horizontal velocity multiplied by time. So the horizontal distance is, okay, x equals to 10 meters. So which means 10 will be equals to horizontal velocity. That will be, we are using u cos theta multiplied by t, and that will be 10 equals to 15.5 cos theta multiplied by t, and this becomes equation 1. Yeah. Then also we know that for vertical distance or vertical height, which is y, that will be equals to vertical velocity. Okay, we have that to be vertical velocity multiplied by time. And in that case, we say y equals to, so we know that y is equals to 8 meters. So we can say that 8 is equals to, now in this case, now we are not going to use, so for vertical distance, because it's, okay, the boy throws the apple. So which means in this case, we are going to make use of y equals to uy, okay, uy, then times t negative 1/2 of gt squared. Yeah. Mhm. All right. So this will be 8. Then this will be, so uy, okay, uy, okay, uy, we know uy to be u sine theta, u sine theta. So u is what? U is 15.5. Then sine theta multiplied by time t, then 1/2 of 9.81, okay, then times t squared. Okay, so this will be 8 equals to 15.5 sine theta multiplied by t. This will be 4.905. Yeah, t squared. Half of, that is half of 9.81. Yeah, that will be 4.905 t squared. Okay, so let's call this equation 2. This is equation 2. Yeah. Yeah, this is equation 2. Okay, so the next thing to do is, now this is equation 1 and that's equation 2. Okay, let's make t the subject of the formula from equation 1 and then substitute for t into equation 2. All right, so I can say that from equation 1, okay, t will be equals to, 10 over 15.5. Yes, cos theta. Okay, it's getting clearer. So this becomes equation 3. Okay, that's equation 3. So then let's substitute for t in equation 2. Substitute for t in equation 2. So that will be 8 equals to 15.5 sine theta multiplied by 10 over 15.5 cos theta. Okay, then minus 4.905 15.5. Okay, then this will be 10 over 15.5 cos theta, okay, raised to the power of 2. All right, so this will cancel this. Okay, so sine theta over cos theta, that will be tan theta. So this will be 8 equals to 10 tan theta. Okay, now this is 10 squared, that will be 100. 10 squared will be 100. So 100 multiplied by, so this will be 490.5 over, then what is 15.5 squared? 15.5 squared. That will be 240.25. 240.25. Then square of this, that will be cos squared theta. That will be cos squared theta. Yeah. So let's get the value. What is 490? Because I did 4.905 multiplied by 100. Okay, which is 490.5. So 490.5 divided by 240.25. Okay, that will be 2.041. Okay, so this will be 8 equals to 10 tan theta, okay, minus 8 point, no, that will be 2.042. Then this will be, now this will be 1 over cos squared theta, and that will be what? Sec squared theta. That is 1 over cos squared theta, okay, is equals to sec squared theta. So that we can then say 8 equals to 8 tan theta minus 2.042. Let's not also forget that sec squared theta is 1 plus tan squared theta. Okay, so this will be 1 plus tan squared theta. So let's distribute that. So we have 8 equals to 10 tan theta minus 2.042 minus 2.042 tan squared theta. Okay, so now let's write this. This looks like this is what we call this is a quadratic equation. So let's write this in standard form. So I'm going to move this from the right hand side to the left hand side so that the equation can be 2.042 tan squared theta minus 10 tan theta. Then this will come here, that will be plus 10.042 equals to 0. So when we move minus 2.042 from the right hand side to the left hand side, so it will be added to 8. Okay, and that's what we have here as 10.042. So here we have a quadratic equation. We have a quadratic equation. All right. So now to make it easier, let A equals to tan theta so that 2.0, okay, let me use a different, let's make P equals to that. So 2.042 P squared minus 10P plus 10.042 equals to 0. So we have a quadratic. So we can say from here that let A equals to 2.042, B equals to negative 10, then C equals to 10.042. So we are using quadratic formula so that P will be equals to negative B plus or minus square root of square root of B squared, then minus 4AC over what 2A. So that P will be equals to, now B is minus 10. So that will be negative minus 10 plus or minus square root of 10 squared minus 10 squared 4 times the value of A is 2.042. Okay, then multiply by 10.42 divided by 2 times A. So A is 2.042. 2.042. So this will be P equals to 10 plus, this is 100. All right, so let's get the value of what is 2.042. Okay, multiply by 4, then multiply by 10.42. 10.042. Okay, so that will be 82.023. 82.023 divided by, I don't want to make mistakes, so 2 times 2.042. Okay, so that will be 4.084. This will be 10 plus or minus. So let's get what is 100 minus 82.023. Of course, that will be, we have square root of 17.977 divided by 4.084. Okay, so let's get the square root of 17.977. That'll be 4 points. So in this case, we have 10 plus or minus 4.24 divided by 4.084. So there will be two values of P. Okay, so the first P, which is equals to, we know that P equals to tan theta. Okay, let's make that theta 1. This now will be equals to 10 plus 4.24 divided by 4.084. That will be 14.24. Okay, 14.24 divided by 4.084. Okay, so tan theta 1 will be equals to, So we have 14.24 divided by 4.084. 14.24 divided by 4.084. That will be equals to 3.487. So that the first angle will be inverse tan of 3.487. 3.487. So let's get the inverse tan of 3.487. Yeah, that will be theta 1 is 73.9. So that theta 1 will be approximately 74.0 degrees. That's the first angle. All right, so the second angle. So we then use again, second P will be 10 minus 4.24 divided by 4.084. Okay, now that will give us 5.76 divided by 4.084. 4.084. So P2, we know P2 to be tan theta 2, which is 1.14. Okay, so from here we can say theta 2 equals to the inverse tan of 1.41. So let's get the inverse tan of 1.41. So theta 2, so this is the first direction. So theta 2 is 54.7. That's theta 2. Now, but now in this case, we can only consider one of these angles, but there is a condition attached to that. The condition is that now let's plug in these values, because while I was solving the problem, you know I'm just saying, I mean, it struck my mind that what if we are getting two positive angles, and we substitute the two angles into the formula for t, which we derive here. Okay. Now, if one of the value of t is negative, then we can only consider the one with positive value, and that will be the direction in which the boy throws the apple. Yeah, that's it. All right. So what I will do is, so what we want to find out now is to know if if one of these two angles or direction we just calculated are mathematically possible, okay, or both are mathematically possible. So if both are mathematically possible, then we can then conclude that the range or the direction will be between 54.7 degrees and 74 degrees. Now let's find out. All right, so which means we can say to calculate the direction, or yeah, to calculate to know the direction, okay, to find out which direction the boy throws the apple. Throws the apple. Now substitute the value of theta, theta 1 and theta 2 into equation 3. Equation 3. Now equation 3 is t equals to 10 over 15.5, then cos theta. So when theta is equals to 74, okay, 74 degrees. So we can say t equals to, that's t1, will be equals to 10 over 15.5 cos 74. Okay, what is 15.5 cos 74? That'll be, so in this case, so this is 10 over 4.272. So what is 10 divided by 4.272? Okay, so the time is positive. So this is 2.34 seconds. Let's note this. So this is what? Mathematically possible. Now let's calculate T2. So for T2, it will be 10 over 15.5 cos. Let's not forget that when theta 2 is equals to 54.7, okay, so this will be T2 equals to 10 over 15.5 cos 54.7. Okay, so what is 15.5 cos 54.7? So this will be 10 over 8.957. This will be positive as well. So 10 divided by 8.957. Okay, so that will be 1.12 seconds. This is also positive. So both values of time of flight are positive. So we can say, therefore, the two angles, 74 degrees and 54.7 degrees, are mathematically possible. And come to the end of this class. Yeah. All right. So, of course, like I said, this requires careful examination. It's not a question that, okay, I know what the formula to solve the problem. I know what the formulas are. So let me just use the formula and get the answer. No, it's a question that we need to, take our time, understand the question. And then when we know what to do, of course, it makes it easier and it makes life beautiful. The noblest pleasure is the joy of understanding. Bye bye.